Welcome back. In the previous video we learned about DCT function. In this video we are gonna learn about DFT function, which stands for Discrete Fourier Transform. The DCT and DFT are similar about the functionality. They are both just switching the domains from the space domain to the frequency domain. But the usage purposes are different, both of them. DCT is used for image compression or video compression. We are using DCT most of the cases, but DFT is used for image filtering or contour extraction. We are using DFT for most of the cases. Yeah, this is some difference and similarities with DFT and DCT. Usage is very easy in OpenCV site, very similar to the DCT function. We are just giving the float type of the input array and it's gonna give us the destination image. I'm not gonna deep into the mathematical background. I also don't know, because I'm just gonna focus on the purpose and the functionality, how we are using this and in which cases we are gonna need this function. So I'm skipping this part. In here, yeah, in also specifying what kind of input. Also they are still missing float type. It's needed float type of images as input image. And there is an example in OpenCV documentation. I'm gonna also show you this example because this is very useful to understand the logic of, the purpose of DFT function. So I'm gonna show you this example after showing how this function is working. Also they are suggesting to check that example in here. Yeah, let's switch to the code part. In here I already have a Lena image. Let's try to directly call DFT function and image and out, and all is done, looks like sim, but it's wrong of course, because this is needed to be float type of image and it's gonna give us error again, just like in the DCT function it did. Yeah, and let's define an image float math and convert our input into the float image, which is in here, and the type is gonna be 32 float type. Okay, and all is done. Now we are able to use DFT function. So what is wrong? Yeah, we didn't give as input image float. Okay, now we get our output. There is one critical thing about the usage of this DFT function. I need to talk about them because this is the most critical point we need to talk. The output of the DFT function, the center, their center start from here, DFT output. But in most of the cases, in most application, you are gonna see that they are shifting this coordinate, this center coordinate, into the center, because usage is getting more proper. After shifting the center into the real center, then you can use the output of DFT in more properly. Also in OpenCV example, let me copy that part. I already copied here to be able to use faster. Let's use that. Also, who is interested the usage, they can also copy the same code into their here, then they can use that one. Okay, let's run this code for example. Yeah, we came here faster, but you see there is an input image in here, and at the end of some processes we are gonna talk about here a little bit, that you get this image. You see here there is a text, and this text, rotated text, you see, and in here in some way there is a light, and you see that light is just showing the rotation direction of the input image. So you are able to you are able to calculate how much rotated this input image with this one. Also there is another image which is not rotated in here in the same directory I have, and this image is stable. The vertical is not rotated, so you see the light in the output of the some process of DFT function. You see it's straight now. So with the help of DFT function, actually you are able to get the text rotation angle, we can say, because this is a very important in some cases to know the angle of any text. So you can rotate it again, you can make it vertical, so you can maybe apply your OCR, so you are able to read the text more efficiently. Yeah, so with this one, for example, with this case, with OpenCV example, you are able to get the rotation angle, so you know how much rotated your text. This is useful. So this kind of image feature extraction example of with the DFT. Okay, let's little look at the code. In here, what they are doing is just converting this to the float as we did in the beginning. So they are just applying DFT and splitting planes. There are magnitudes very similar to the DCT function. DCT has coefficients. They are just using magnitude function. We didn't learn about this one, but in the future videos we are gonna check this also. They are making, for visualization better, they are making logarithmic function they are using, and this is the critical part which I am talking about. Here they are, you see also there is a command in here. They are rearranging the coordinates. They are shifting actually. There is a geometrical logic in here. They are just getting from left top, and that point they are getting into the center, which we talk, because as I said, in the Fourier transform the origin starts from here. They need to get back into the center, and they are doing in here. At the end they are normalization. You can also use different kind of to visualize the output image. Then after that, yeah, you see this light, very easy to calculate the angle. You see this is 90 degree. You can decide, okay, my text input is vertical. If in another case, if it's rotated, is this light angle, this direction is gonna be also calculated easily. Just get this line, very easy to get, and calculate the angle. Okay, this is rotated. If you convert, if you use this angle, just rotate back and you can make this horizontal again. So with the help of this, you can, let's say the most usage is just you can able to apply OCR, let's say, so you can read all the text properly, because in the rotated text OCR is not working properly. So this is one of the real world example, the usage of DFT. So OpenCV already made a good example. I just wanted to show you, and you can check also by yourself. So in this video, basically I wanted to talk DFT usage, DFT purposes. So yeah, I'm done for this video. See you in the next videos.